Alright then, hello guys. Today we're doing another PicoCTF challenge, and the challenge we're going to be doing today is going to be called format-string-3, which is part of PicoCTF 2024. So how do we do this challenge? So for this challenge we have to download the 4 binaries, which I already did, and the ones that I needed to change permissions were format-string-3, LD Linux, and libc. So you need to change them to be executable so you could run the binary format-string-3. So format-string-3, it gives us howdy gamer. It'll be nice. Here's the address of setbuff and libc, and it's exactly that. And now if we type a bunch of letters, we see that it repeats it out and it repeats out bin.sh. So let's look at the source code. So by looking at the source code, let me just quit that. Oh, how do I do clear? If we look at the source code, format-string.c, we see a bunch of functions being run, but the one that I guess interests me a lot is probably the bin.sh, and then it gets put out right here. Prints out bin.sh, and then we see right here along with the get and then printf, but it basically we print f, but without no I guess no indication of what we're gonna be printing out, because with printf there's a vulnerability with string format vulnerability where an attacker is able to manipulate printf to print out variables within the stack, or you can overwrite stuff. And what we're gonna do is basically overwrite puts. We're located right here, overwrite puts, but this time we're not gonna put puts. We're gonna be running system, which is gonna basically get us a shell into this flag, or into this instance right here. So how are we gonna do that? So first, what we want to be able to do is locate system sh onto. We first want to be able to locate puts and systems sh puts, and also want to be able to first locate puts and system both in libc. So how are we going to do that? So how we basically locate libc system is we could basically go gdb and then no, let me see, ls, yeah, gdb libc. So, and we need to do functions, info functions, functions system, and let's do info functions. I think this should work too. We could look for system right here. System sy. It's gonna be hard to find system because like everything's mixed up here. It's gonna take a while to find it, but what we could do is do even a simpler shortcut, which is basically we could probably use Python. So Python solve.py. So with this, what we're gonna do is basically do from pwn import all, and then we're gonna do elf equals context.binary, which is gonna set our binary to match the elf, and then it's gonna be set to / format string and then 3. So now if we run this, we're gonna see a bunch of stuff right here. So we'll just run this. We're gonna wait for this to run. So we see right here, we get partial, real, raw, canary found, and annex enable. So what does it mean by canary found? That means that basically that there's a stack canary making the addresses random, so it won't always be the same. So how do we stop this? So first thing what we want to be able to do is start up our binary. So we'll go to nano solve.py. So we'll go to nano solve pi, and then from here what we're gonna do is we're gonna do p equals elf dot process, which is gonna run our binary. This is gonna run our binary. And now with that, we're basically gonna do p dot receive until that memory address that it leaks, because if you look at the program itself, it basically leaks out a memory address that we're gonna use OX. So now we have the memory address in our hand. So what are we gonna do next? So if we go back to the binary format string 3, we want to be able to grab this memory address because it leaked there randomly from libc, which is set vbuff. So how are we gonna grab it? So we're gonna go to nano solve.py. We have it right here, receive into the hex value that we saw beforehand. So now what we're gonna do is we're gonna set that value. So set vbuff underscore leak equal to, we're gonna turn it into an int, and then we're gonna do p dot receive into we reached a new line, because if you look at it closely, it reached it up to a new line. I'm probably gonna change this to bytes, and then we're gonna do drop equals true, and then we're gonna decode this into base, and then we're gonna, just for you guys can notice what it is, we're gonna do print set this right here, set buff leak Python. It's running the process. We're gonna wait for this. Is it not running it? Oh, I think because I didn't close it. P dot close, I think. P dot close. Something like that. Oh wait, you know what? I think I know where I messed up. There's like a space right here. Doesn't do it all together. So maybe that's why I didn't reach it. So now if we do that, cannot convert non-string with explicit base. So it says int decode. Let's go set buff leak int. Now we have do p receive recv until, and then we're gonna have base bytes. The b is for byte string. Drop equals true. Then dot decode. Oh, right here. 16. So now if we run this, we see that we got, I guess, the hex value straight. And I'm pretty sure if we run this again, it should be random since. Yeah, see, look, see how it's always changing? 5568, 5528. So it's always gonna be random because of this canary found right here. So it's never gonna be the same, but we that won't matter to us. They gave us libc, the one that they're running. So you'll see what I'm gonna be doing. So nano.c.py. So now we got libc. No, now we got the leaked address. So now what we're gonna do next is basically set libc. So we're gonna do libc, and let me check if I'm still recording myself, because sometimes I'll be moving my mic and then it stops recording. So we're gonna do libc equals elf, and now we're gonna set our libc value that they gave us, or our libc file. So we're gonna do libc.so.6. Now from there we set our libc value, and now what we're gonna do is gonna do libc.address. And now what we're gonna do is set it to equals our whatever we leaked minus libc.symbols, and then we're gonna just focus on our system value. Oh no, not libc symbols. It's gonna be our set buff, because that's the one we want to match it to. Set vbuff. So now from here on out, we're gonna know the difference between these two. We're gonna be able to find the canary. So we're setting our libc value because we know that set bfluff, whatever is leaking, it's always gonna be random. But this libc address is always gonna be the same. So all we need to do is basically subtract the two values to set it up, so that it won't be randomized on our end. So now if we run Python 3 solve.py, we got it. So now we go to nano. Now what we want to be able to do is basically get our system address. So sys address equals to libc dot symbols, and then we're gonna just import our system value right here. This now holds system, and then we want to get our put address equals libc dot symbols dot put, because at the end of the day, if we look at our cat format string dot c, we see puts being normal string being put in puts, but we want to set this to system. So how are we gonna, I guess, do this is that we're basically gonna overwrite it. So nano solve, we're gonna write it using this. We're gonna put address, which is this one. We're gonna overwrite the put address with system address, which is what we got from right here. Now to be able to do this, Pwn Tools has a specific automation tool that does it for us and makes it pretty easy. Format string bug exploitation. So provide someone to exploit format string. Let's put this as an example. And this is the example that they have where in this case they want to overwrite an address with this value right here. They want to overwrite address with this OX 01337 babe. But right here they don't make it. We can automate the exploitation of this process like this. And this is how they do it. It said parent can rewrite so many bytes. Examples of automated payload right here. So you want to be able to, I'll assume a process that reads a string and gives this string as the first format of printf all call. This is processly. So what this does is function callers this automates our process to overwrite certain variables inside. So what we're gonna do is just copy this. Or we can probably copy this payload thing. We don't have to copy that. We'll probably copy this one. We'll probably copy this one. Except CNCP process is gonna be ELF dot process, and then we're just gonna close this, and then p dot setline our payload, receive all. We're just gonna change this to equals receive all. What is this? We're gonna do p dot close, and then return L. So what we're basically gonna do here is basically run this payload. Payload is gonna equal fmt str format string payload is gonna equal our offset, which it does it automatically with writes. And what we're gonna do right here is get and go right here, offset is gonna equal FMT_str, and we're gonna do this right here, xfmt dot offset. So this is basically gonna find our offset needed to overwrite our variable of puts with system. This does it automatically. If not, we would have to do this manually and find the offset. But with this in play, this makes it a lot more easier. So now we're gonna do p.sendLine with payload, and this should p.interactive, and we could probably comment this out right here because we're gonna have a shell at the end of the day. I'm gonna close this, and then we're gonna do Python 3 solve.py libc puts right. So now if we run that, got end of file, got more while sending to interactive. And I think it might be because we're on our system, but if we could probably change this to be something else. We could probably change this to be our PLF, ELF process. We could probably change this to be the thing we want at the end of the day, which is the actual this thing right here. So you just probably copy that. Because I'm assuming because we're not on the right we're not on the right how should I say this? We're not, I guess, on the right Linux server that they have on. So we probably just change it like this. Question mark. And then do this. P remote nano solve. So ELF context binary format-string-3 p equals LF send line payload p receive all p dot close return L offset FMT and then str, and then the extend payload, but we did exefm_ft dot offset, and then p dot remote, and then whatever our remote binary is, p dot receive into, and then set buff leak, and then print libc equals elf libso libc address equals set buff leak minus lib system set vbuff system address equals lib symbols elf got, which is basically our file, which is basically this right here, format string. So this is where I messed up. So now if we do this, we have an interactive shell, and now we could just cat our flag. We got it like that. We got it. I guess the only reason this works is because it's basically print string format string vulnerability overriding got. That's basically the name of the tag. Format string vulnerability overriding the got, which is basically the got table, which I guess holds values that holds values right here. Arbitrary execution. And then let's ask ChatGPT. Let's ask Bing. Bing is my favorite one. To override got. So it says so an attacker can use format specifiers like to leak memory addresses, which is what we did because they already got leaked for us, and then writing memory. So the end specifier allows us to write values to memories, which can be exploited to overwrite the pointer to the modifying critical variables. And this writing to the memory, this is done by this function from right here, cat solve.py. This is done by our automation right here from Pwn Tools, and then got overwrite. The store address dynamically link function of an attacker can overwrite the entry in got, which is replacing printf with system binsh that hijacks the execution. So that's where we got the got overwrite. We're able to overwrite the got from the file format string, but except with printf, we overrode puts right here. Puts address gets overrode with system, and then we send in the payload, which does the automation to find the specifier that allows us to write to memory. We send it and we get interactive shell. So that's about it for this challenge. Hope you guys learned something new today. I know I did, and I'll see you guys in the next one. Peace.